Okay, so I'm going to be talking about friction and nanoparticles, how those two are related, and how we can see examples of both in the animal kingdom. So, friction, just to be generally defined, is the resistance force that's applied to an object when, one object kind of slides, rolls over another. For example, a soccer ball. This soccer ball is having a force that was exerted to it, when someone kicked it, most likely, and force is pushing it forwards, but the grass is causing that friction to act on the soccer ball, which is a resistance force, um, as you can see, going this way. And so eventually, the ball will stop rolling due to this resistance force. Um, but the But should the soccer ball be kicked on a tile floor, it would take a lot longer for the ball to stop rolling because there's a lot less of a resistance force at work there. Um, and you're probably wondering what on earth what on earth this friction has to do with nanotechnology or nanoparticles, but let me tell you why. Because when an object gets small enough, the regular rules of friction stop applying. And instead, a force which the science world calls stiction starts applying. And stiction, instead of being a resistance force that acts upon an object, it's a force of attraction instead. And so that attraction force is something that we can see a few examples of in nature, one of which I'd like to talk about now. This is the example that I'd like to talk about. This, as you can see, is a snake climbing a tree. And it's, kind of a great question. How do snakes just climb up the tree without, falling over? And the answer is because that rule of stiction, due to the nanoparticles that the snake's skin contains, that it's creating that stiction, that force of attraction, as opposed to friction. And so that's how the snake is able to climb up the tree. Because of the forces being exerted by the bark and the snake's skin, they're able to keep the snake from falling off because of the stiction force. The force that is attracting those two together.